Twin, you suck at trapping, and this is how I know. So let's say we want to find the shortest route to serve every location, then head back to the trap. We call this the trapping salesman problem. So we have our locations in the list and our distances in the matrix. So the first thing we're going to do, we're going to create a function called cost to calculate the total distance of each route. So we create a variable called total in the for loop to go through the length of the route minus 1. We do minus 1 so we won't get an index error. In the for loop, we're going to write a line to calculate the distance from the current location to the next location. In each iteration, we're going to update the total. And we keep doing this until we go through the whole route. But remember, when we serve all the locations, we got to head back to the trap. That's what the line after the for loop does. Now we're going to create two variables, one to store the minimum cost and one to store the best route. Then we can use a for loop along with that permutation to generate every possible route. But if we start the for loop at index 1 instead of 0, we only have to get the permutation for 4 locations. This helps us cut down the possible routes from 5 factorial to 4 factorial. So that's 120 routes down to 24. Then we could just add the 0 index to each route. This makes the time complexity big O of n minus 1 factorial, which means you suck at trapping and you need to stop right now if you're doing this method. Now we create a variable to store the current cost to each route. Then we create an if statement to check if the current cost is less than the min cost, and if it is, we update the min cost in the best route. So basically, every time we find a shorter route, we save it. And you see when we run the code, we get the best route to start trapping.